Okay, imagine you're working at a game company. They are building this duck simulator where different ducks are swimming around on the screen. You have mallard duck, redhead duck, and yellow ducks. And your manager comes and says, "Hey, can you design this?" And you're like, "Yeah, easy. We know OOP concept. We'll make a base duck class." Because all of these are ducks, right? So a parent class make complete sense. So we create this duck class. Every duck can swim, every duck can quack, and every duck can fly, and every duck can display itself. Then we create subclasses like mallard duck, redhead duck, and yellow duck. And honestly, at this point, the design looks great. We are using the code, we are using the inheritance, we feel like proper OOP engineers. Nothing is wrong yet. Then, as always happens in a real project, a new requirements comes in. The product manager says, "Hey, can we add a rubber duck now?" And you say, "Sure, it's a duck. Let's make rubber duck extends duck." It still sounds correct, right? A rubber duck is technically duck, so what could go wrong here? You run the application and suddenly the rubber duck starts flying. Why? Because it also inherited the fly from parent duck class. The parent says every duck can fly, so the child automatically gets that ability to fly. But now we have the rubber duck as well. So this is a toy duck. It should float, maybe it should speak, but it should not fly. This is where people usually realize, okay, inheritance is not always as simple as it first looks. So what's the obvious fix? We can override fly. So in rubber duck, we say, okay, this duck has a fly method because of inheritance, but it does nothing. And for sound, instead of quack, it squeaks. Fine. So it works, right? But then another requirement comes in, a decoy duck. This one is basically a wooden fake duck. It cannot fly, it cannot quack, it just exists and look like a duck. So now we override fly and make it do nothing. We also override quack and make it do nothing. You can already feel the design is getting awkward. We are inheriting features from parent class and then immediately disabling them in a children. This is usually a clue that the behavior is placed in the wrong class. At this point, someone in team says, "Let's remove the fly from duck. We'll make a flyable interface." Sounds like a solid improvement, right? Now, only duck only ducks that actually fly will implement this interface. So rubber duck and decoy duck don't need a fake fly method anymore. But now we hit another problem. Look at all these flying ducks: mallard, redhead, yellow duck. These all have basically the same fly code. So if we change how flying works later, we have to update in all the classes. So if we fix the wrong behavior issue, but now we have copied the same behavior everywhere, which caused the code redundancy. And like it's very hard to maintain it in future. So instead of trying another random fix, let's step back and see what actually changes in the system. The fact that like something is a duck that's stable. Its display logic is stable. Shared duck data is stable, but flying can change as you've seen. Some ducks fly with wings, some don't fly. Maybe later one flies with a rocket. Quacking also can change. Some duck quack, some squeak, some stay silent. So that is the idea. Pull out the part that changes. Don't keep that changing logic trapped inside a duck hierarchy. So now, instead, let's make flying its own thing. We create a fly behavior interface. It just says anything that represents flying should have a fly method. Then we make one class called fly with wings. This class knows how to fly a normal duck. And we also make another class called fly in OA. This represents the duck that cannot fly. Both follow the same interface here, but they behave differently. And this is very important. These classes are not ducks, they are just the behavior. So one job, one responsibility, decide how something flies. Now here's the actual shift in the thinking. Earlier we had said a duck gets flying behavior from inheritance. Now we say a duck has a flying behavior. A duck class has a flying behavior object. When we call perform fly, duck does not do the fly itself. It simply says, "Hey, my current flying behavior, you can handle this." This is called the delegation. Ducks delegates the work to another object. For example, this model duck starts with fly no way. So initially it cannot fly. But later, maybe in the game, we attach a rocket to it. So we don't need to create a rocket duck or rocket rubber duck class. We just replace the behavior object. Same duck, different behavior. That's the power. And now we can give this design a name. So this is the strategy pattern. Duck is the object using the behavior. Fly behavior is the common contract. And these are different strategy. Fly with wings, don't fly, fly with a rocket. So whenever we have different ways of doing the same thing, we can put each way into its own class and swap them when needed. Now let's take a real world example. Imagine a checkout system. You might support Razorpay, Stripe, PayPal, or any other like MasterCard or Visa, any other service. You don't want one huge if-else block statement like if Razorpay do this, if Stripe do that, and so. Instead, you create a payment strategy interface. So then Razorpay become one strategy, Stripe can become another, and so on. Your checkout service just say, here's the amount and process the payment. It doesn't care about what provider specific implementation. So the simple key takeaway is if behavior keeps changing, don't keep adding subclasses. Don't keep overriding methods with empty implementations. And don't let one giant if else grow forever. Put each behavior in its own class. Give them a common interface. And let your main object use the behavior it needs. This is called the strategy pattern. And honestly, once you start noticing it, you will see it everywhere like payments, notification, pricing rules, fraud checks, authentication, shipping logics, and everywhere. In the next video, we will do observer pattern. That's one is specifically useful for events, notification, Kafka style system, and real-time systems. Thank you so much for watching this video. Please like, share, and subscribe. Peace.